Yes.
Jess, I was trying to find some others.
Some parties?
There's no party. There are no party. We did the party yesterday.
Test is gonna have a party.
I think I'm partied out.
Okay, you party pooped?
I'm party pooper.
Did you ever do the dance?
I don't
Remember
think
you said
You
you were
never
gonna do a
sang
dance
it.
and then you
The
never
tangent
did?
line
you said there were
dance.
songs and dances for some stuff.
Interestingly enough, 4th and 5th got the dance.
What the
Yeah.
heck?
We dance. We always get.
Well, because the
You
camera.
got gypped.
I always get jokes.
I will dance for you before prom. At prom too.
Are you That's going so to far prom? away.
Yeah.
Go to prom, do the math dance.
I'm in charge of prom.
Oh yeah, I forgot.
What's our thing? I even forgot.
Great Gatsby,
But
baby.
like, what is it? Like,
I haven't made it yet.
Yeah,
3?
yeah.
3's enough, right?
Yeah.
Is that what we're finding?
I'm done.
So I need to look at all the food.
I just did something called my professional growth plan and incorporated Nick's videos into the professional growth plan. Pretty cool.
How about that?
Yep. I appreciate it. How about that? I know, I was so excited. And I said, and I even have a student, that. Okay, so if I'm looking at this, before I even look at the problem, say, this says, the function f is given such that f of x equals 3 over 2x plus 5 for x is an element of the reals, x does not equal negative 2.5. Why do they give me this junk other than to scare me?
Because when you do that, it's an asymptote.
It's an asymptote, right?
Find it,
So
x
I
does
know that-
equal negative 2.5, but it can't equal it.
Right. I can plug any x in that I want, any x, except negative 2.5. That's what that means. So a lot of times people will see that in the first line of the question and go, yeah, moving on to the next one. Because they have symbols that look kind of funky. Don't do that. Understand that that's all it's talking about.
What is the e?
Element. X is an element of the reals. It's referring to the domain, really, if you think of it that way.
Sounds like a Twilight Zone.
I know it does, an element. Okay, the first thing says, obtain an expression for that, and explain why f is decreasing. Okay, question. Why are they what is that?
Derivative.
The derivative, the slope. And the second part of this question has you doing this. What is that?
Inverse.
Inverse. Why do they put those together? Truly to confuse you, right? Honestly, I mean, just think about it. They're doing this symbol and that symbol as part I and part II. Which one am I going to do? Which one matters? Which one goes with what? So you have to kind of remember what the symbols mean. It's a great problem, Nick. I'm glad you picked it. So it says obtain the expression for this and explain why it's decreasing. So let's start there. So we have to go ahead and find the first derivative. You guys told me the gradient. So I'm going to take this thing, and the first thing I'm going to do to it before I do anything to it is rewrite it. Bring it to the top. Because I know that I cannot take a derivative of something that's in the denominator. I know that that's not possible. Another method that I could use to take the derivative of this is blank. If I bring it to the top, I'm using what method? If I don't bring it to the top, I'm using quotient rule if I leave it at the bottom, and chain rule if I leave it at the top. Okay? So you can choose which one. A lot of people feel very comfortable bringing it to the top and using chain rule. Okay, f prime. So how do I go about doing that? Well, the 3 goes for the ride, and that comes to the front, be -1, right? So times -1, and then rewrite junk, -1 times times 2. Questions, comments, concerns, issues? Yes, no? Hand just went up, but not really up.
Never mind,
Yeah,
cleared
it
it
was
up.
kind of like half up. All right, so we took the 3 for the ride. We used the chain rule, which meant we take the derivative of the outside stuff and then multiply the inside stuff to it. Everybody good with it now? Okay, so cleaning her up a little bit, I know that this is a positive exponent, a positive exponent, a positive exponent, so those things all go together, right?
Right.
So 3 times -1 times 2, right, would be -6, and I see a negative exponent, so I'm going to bring that thing right down to the bottom. Okay, so at this point, this is probably a 3-point question. Nick, correct me if I'm wrong.
It's, yeah, 3 points.
Okay, so it's a 3-point part to the question, and so far I probably would have earned probably 2 out of the 3. Okay. The next part is pretty important because on a test, probably about 4 years ago, the question number 1 was find f prime and then tell me why the thing is increasing all the time. And they had absolutely no clue. Actually, you know what? It didn't even say find f prime. It just said explain why f of x is increasing all the time. Okay, so one of the ways you figure out whether something is increasing or decreasing is by using the first derivative. Because if you think about it logically for a minute, typically when we do the first derivative, we're trying to set it to 0, and we set it to 0 to solve for x. And what does that x represent when we set it to 0? When we set it to 0 and we solve for x, it's representing?
It's the x value of the stationary point.
Absolutely. It's the x value of the stationary point. So normally when we set it to 0, we're finding the top of the hill or the bottom of a hill, right?
Yep.
So for me to get to the top of the hill, what do I have to do? I have to rise, hit the hill, and then fall, right?
Uh-huh.
This is referred to as increasing. This is referred to as decreasing.
Mhm.
So far, so good. If it's vice versa, if it's the bottom of the hill, when I set it to 0, I'm going to fall, then rise. So decreasing to increasing. Is everybody okay with that? What causes the stationary point is when the first derivative is 0.
Mhm.
What causes it to be increasing? Well, it's if the first derivative is greater than 0. That meant that if the first derivative is greater than 0, the original function increases there. If the first derivative is less than 0, that means that would be decreasing there.
Mhm.
So greater than 0, meaning all positives, increasing. Hit the top of the hill when it is 0. If it's less than 0, decreasing. Everybody cool with that?
Yep.
So fast forward to this problem right here. We took a first derivative, we cleaned it up a little bit. Tell me what you know about the top. It's always negative, right? Tell me what you know about the bottom. Why?
Because
Because it's squared, okay? So if I know a negative divided by always positive, the answer is always going to be negative. So that means the first derivative is less than 0, right?
Yeah.
Does that make sense? And if the first derivative is less than 0, then I know that this is always going to be decreasing. Now the question itself, does it say explain why?
Yeah.
Okay, so the explanation can't just be f prime is less than 0.
Oh.
You can tell me that f prime is less than 0 because, and tell me why. Because the numerator is always negative, where the denominator, because it's squared, is always positive. And really, just tell me in words. That's all they're looking for. Okay, so because the numerator is always negative, and then the denominator, right, is always positive. That's, you know what I mean? Because it's squared. Because it's squared. Yeah, go ahead.
So I looked at the mark scheme and they just said it is decreasing because f prime of x is negative.
Sure, but I think a little further.
Mhm.
Explain why you know that. But 100%, we've got this written down, but I want you to tell me a little bit more why you know that.
Mhm.
Just for the sake of making sure that they understand that you know that.
If
Uh-huh.
you, instead of writing out, and you get like, if you plugged in a negative number to the bottom, and you end up getting negative, you plug the positive, can you show it using math, or do you have to write it?
Well, okay, so if you were going to show it, I explained a technique to you earlier on in the year called the chart.
So if you did the chart.
If you did a chart. So how would that chart thing work? Well, what you would do is you would take your first derivative and you would set it to 0 and you would solve for the x that is the stationary point. And then from there, what you would do is you would go to the left of that, whatever that stationary point was, right? And then to the right of that stationary point, and you would actually plug into the first derivative. Seems like a whole lot more work.
Okay, I was just curious.
Mhm.
Once if you instead of doing that, and you just plugged in like -1 and then 1 to x, and you solve for y gets both negative, would that count or no? Just curious.
Because there's multiple answers that you could potentially plug in, you would actually have to work around the stationary point.
Okay.
Yeah, because you wanted to show that to the left of that stationary point, it's always negative or positive.
Okay.
So I would say no. I would probably use this right here. So like I said, that one year they all came back and they completely skipped number 1. because they were like, well, we didn't understand how to show that it was always increasing. I was like, easy points. Okay, so are we good?
Mm-hmm.
All right. So that was, I think, easy 3 points. Now the next one says now it wants me to find the inverse of it.
Uh-huh.
Okay, so this is back in 2009. Are they flat out going to ask us to find the inverse of something? Yeah, maybe. Sometimes they incorporate sines and cosines in there now.
Mm.
They make life good. So, how do we go about finding the inverse of something? Review the steps, yes.
You rewrite it as y equals,
Yep.
and then you flip the x and y and solve for y.
Okay, so rewrite it as y equals. Okay, step 1. Step 2, interchange your x and y. So x equals 3 over 2y plus 5. So far, so good.
Mhm.
Then multiply to get y by itself.
Get rid of that denominator. Scared of fractions, right? So bring that guy up here. And then it's times x equals 3. So far, so good.
And then you want to get y by itself.
You're eventually going to get y by itself. So
Distribute the x out.
I don't think I'd distribute the x.
Divide by
I would
x.
divide by x, right.
Yeah.
Because if I'm divided by x, that's one less obstacle that I have to attach to that y. So subtract 5, divide by 2, yeah.
Or multiply by 1/2.
Or multiply by 1/2, right. So we have 3 over x minus 5, so far okay?
Mhm.
And then you said multiply by 1/2 because it's a little easier than looking at divide by
Yeah.
2. So if I multiplied by 1/2, do you guys agree I would have that?
Yep.
And that's perfect. And then tell me what it is. Well, it is the inverse. Did it want me to do anything more to it, or did it?
Just obtain the
Yep.
expression.
Nice. How many points? 2?
2, yep.
Yeah. That's about a 2-point set of work. Yeah.
So you said today they'd be using sines, cosines, and tangents?
I'll find one for you eventually when we start studying.
Because I don't think that, like, when we did the inverses, we didn't work with
No,
that.
because I hadn't taught you sines and cosines yet.
Mhm.
So, yeah. So it would be something that we need to kind of work with. How do you find the inverse of a sine? If I'm trying to get x alone and get the sine over there, what do we use? Inverse sine, right?
Oh, yeah, right, yeah.
So we know the topic, we know the concept, it's just how to correlate it to that.
Yeah.
Okay, so now what's the last part?
At the curve has the equation of y equals f of x, find the volume obtaining the region bounded by the curve, coordinates of x's and the y. Line is x equals 2 and rotate 360
360?
about the x-axis.
And it goes from what, 0 to 2? Is that what you told me?
It's just x equals 2, so I'm guessing 0 and 2.
The region is bounded by the curve, the coordinate axes, and the
Oh, the
line.
coordinate axes. What does it mean by the coordinate axes?
The x and y
The
axis,
x
so
and y
x
axes.
is 0.
So therefore it's 0.
Yeah.
Right, good. I like that we use that word. The coordinate axes sometimes trips people up as well. Okay, so I know it's going to be the coordinate axes, whatever the curve is, and 2. Do I care what the curve looks like? No.
No.
I don't. I just know that it's the curve, the axes, and 2. Truly, that's all I care about. Okay? And which way is it rotating?
About the x-axis.
About the x-axis, 360. I kind of heard you start to say 360. And then, is it attached to the place at which it rotates?
Yeah.
Yes. So therefore, it doesn't have a hole. It's the disk method. Beautiful. And then, also, is it a party or not?
No party.
Parties. I think we've partied out. So what we're going to do is we're going to go pi. Don't forget the pi from 0 to 2.
Mm-hmm.
Okay. What's my ceiling? What's my floor? The equation of the curve
Yes.
minus 0.
0.
So minus 0 doesn't matter to me, or does, but doesn't. So 2x plus 5. And don't forget to square it.
Yes.
I think in 4th period I was finding they were forgetting to square it. They were
Yeah.
forgot to square it. So I don't know how to remind you to.
Why is it 0 minus 0?
Because it says the coordinate axes are part of my wall and whatever those are my boundaries. So it's curve, axes, and then 2. So if I was to draw the person,
Then they're just such.
then they're touching the 0. Okay, so we did a few of these that looked like this yesterday. Things to do before we even start to integrate. Square the 3 and bring the bottom up, right?
Yes.
So two things can happen at once, really. So from 0 to 3, we have 9, and then we have 2x plus 5.
0 to 2.
Yep, that too, thank you. Where did that 3 come, maybe, I don't know. I've lost it for a minute. So I took the squared and incorporated it into it, and then I flipped that guy up, which made a -1 to the second power, right? Is everybody comfortable, or was that too fast? Are we good? Deanna, you good?
We just automatically put it out.
I would automatically take the 9 out. On a personal level, I would prefer to go for the ride. Okay? Is that good?
Yes.
So, because it just kind of gets in the way. So now we're going to integrate. You can use the easy method, or you could use the
Use substitution.
We know Kalia's going to use substitution, but some of us will use the easy method, whatever one you prefer. It doesn't matter, it gets you to the same spot. So we've got 9 pi, and it's going to be keep the stuff on the inside, add 1 whole, put it over itself, right?
Mhm.
And then multiply that denominator by 2. I like that method too. I thought that was pretty cool. And then we're going to assess it from 0 to 2. That line really tells me you're done with the integral. Now you have algebra to do. Yesterday we also talked a little bit about this denominator. I can kind of shift it over here to this number. Get it out of my way. So instead of having 9 pi and then all that junk over that, I shift it over. I'd have 9 pi over -2 or -9/2 pi, right?
Yeah.
I think personally I like to get all those numbers out of the way and then put them back in at the end. So it would be -9 pi over 2. And then if I clean this up a little bit, I got 1 over 2x plus 5 to the first power from 0 to 2.
What is it?
Wait, what?
Okay, so I took this guy and I shifted it over, and then I just flipped that guy back down. Is everybody good? Now what? Plug in the 2, then plug in your 0, subtract those numbers, and multiply it by -pi over 2.
Wait, what do you do?
Okay, so we're going to plug in 2 first. See, really, I'm plugging it into this thing. This is going for the ride. So I've got, if I plug in the 2, I've got 1 over 2 times 2 is 4, plus 5 is 9. So 1/9 minus, if I plug in the 0, don't be complacent, 1/5.
1/5.
Everybody okay
Yes.
with that? So minus 1/5. Don't forget to bring that 9 pi over 2 for the ride. Thank you. I put the negative, I just didn't say it. And then we have to do what? We have to get a common denominator, 45, right? So 5 over 45 minus 9 over 45, -4 over 45, which is a good sign because we do want it to be negative. Why do I want it to be negative?
Because the volume can't be negative.
Right, yeah. Okay, does that make sense?
Yep.
Because when I subtracted them, I want it to be negative because this negative out front would have to negate something to make it negative. So you guys know how to reduce it before you multiply, I think. Like the
Yeah.
2 goes into here twice, the 9 goes into here 5 times, right?
Yeah.
So it'd be 2/5 pi. All done. What do you think?
So that's the final answer?
Yeah,
They also had 0.4 was acceptable. 0.4 pi.
cool. Which is the same answer. right?
Yeah.
Yes, question? I lost you.
How did you just do that?
How did I do which one?
Just whips it out.
Like, how did you do like
Okay,
all of that
so-
in like 2 seconds?
In my head?
Yeah.
I know, I'm so sorry. So, do you agree 9 and 5 have to go into 45,
Right.
right? So to make this a 45, it has to be 5 over 45.
Yeah.
To make this a 45, it has to be 9 over 45. So I don't care about the 45s for a minute,
Yeah.
right? What's 5 minus 9? -4 over 45. So that's that part. Now this is what I think is the easy part. If I have things that reduce top to bottom or diagonally, I'm going to do that before I
Oh,
multiply.
you did the. Okay. I
Uh-huh.
see what you did. You like crossed it out.
I did, because on a personal level, I don't want big numbers. I'm scared of them, you know that. So I start to reduce it a little bit and say, oh, look, that's gone, I have a 2 and I have a 5, that's all I got left. That's just an old lady trick. All right, are we good?
Yep.
I like that problem because I have seen more recently, not necessarily with an axis of rotation part I, but I have seen them put derivative and inverse together a lot. Like first find the derivative, then find the inverse, nor do they tell you what each of them are. And it's so easy to quickly see the little one here and think, oh, that's an inverse. You know, I don't know. It's easy mistakes to be made. Yes.
When the thing is like when you took the derivative and the inverse, it had nothing to do with part I.
Nothing.
So if you didn't know how to do one of them, you could still go ahead to the other parts
Absolutely.
and do them.
Mm-hmm. Absolutely. Which is a good sign. That's a good thing. All right. Are we feeling good? Comfortable? Confident? All right. Yes.
Are you gonna do something like that on the quiz? Like,
Probably. Well, I'm gonna try to. I haven't made it yet.
Well, we have one that like rotates on the x-axis and one on the y.
My goal is to try to find a Y, but I don't know if I've exhausted my parties.
Okay.
I found one, but like I told you when I first started teaching it, it is far and few between that they introduce this. But I wanted you to have at least a base what happens if you get to this one this year and there's a party.
Will
I have a
all
feeling
the
they will.
pictures, or will it be like this one? Where
Not necessarily.
if we're not gonna be here because we're on the Gatsby field trip, do you want us to take it on that Friday?
Yeah, Friday morning. That's cool. I'll be down in Miss Matthews' room selling prom tickets.
Okay.
So,
So you want us to go there?
yeah, it'll be good. I'll bring it with me because I'll be on the team.
Or do we just go pick up our prom together?
Yeah, you pick them up. Mm-hmm. Yeah.
Are you going on that field trip too?
I am. You can go and watch the video of, which I put in my PGP. I'm so excited about that.
You know, I actually did not do that one, so I guess I didn't do all of them. Except for that.
Ah, Nick, there we go, we found one. He saw 9 points and said, I'm done, moving on. I know how you are. That's funny. Okay. I guess I'm gonna have to steal your paper. Because I don't have. The equation is y equals 9 over 2 minus x, that one? The very bottom one.
Yeah.
Okay, let's do it. October, November, 2010/11, 11. And it's y is equal to 9 over 2 minus x. And the first thing says, find an expression dy dx and determine with reason whether the curve has any stationary points.
I'm gonna do it unreasonably.
You better not.
What does that
Okay.
even mean? Like,
So take the derivative.
So take the derivative.
no, like what does it mean? Like with a reason?
I think you'll see when we do it.
Okay.
Okay? So, first thing we're going to try to find is dy dx, right? Before I find dy dx, I think you agree we should rewrite it. Or you can use quotient rule. Low d high minus
I don't like that.
I can't remember the loading.
low d high minus high d low low low. Oh, bless you. That's,
For chain.
all right, prefer chain.
Yes.
So 9 goes for the ride. -1 comes to the front.
Yes.
Rewrite the inside. Subtract 1 whole times the derivative of the inside. Does that ring a bell?
It's just 9 times 2 minus x to the negative 2.
So it is 9 over 2 minus x squared.
Would it be any time we have to use the quotient rule, or could we always use the other one, the chain rule?
Why would it not be -9?
You would have to use,
The outside one.
I would use a quotient rule if there's an x stuff on top as well.
If it's X one.
I would, because then, otherwise you're bringing up and instead of using just the chain rule, you'd have to use the product rule and the chain rule.
So there's an X on top and bottom, that's what you do?
Yeah.
Okay.
Yes.
Let's get the 2 negative ones.
Okay, so this -1 came when I brought this down to the front. And then when I take the derivative of the inside, I get -1. All right, so now it says find the derivative and explain with reason whether this has a stationary point or not. Yeah? Okay. So question is, how do I assess whether something has a stationary point? How do I assess where the stationary point is? Set it equal to 0,
Zero.
right?
Yeah.
So I'm gonna take this guy, I'm gonna set it equal to 0.
Mm-hmm.
Now what? No? I don't like fractions, so what do I do?
Multiply.
Yeah, all right, you know that. So I'm gonna multiply both sides by that denominator, and I get 0 times 2 minus x squared, which is
9 equals 0.
Tell me what I need
That
to,
don't make sense.
right? So explain with reason why we don't have a stationary point.
Because 9 can't equal 0.
Because 9 can't equal 0. There is no place at which the first derivative is equal to 0. Does that make sense?
Yeah, you
There is no, that sounded so good the first time. There is no place at which dy dx, the first derivative, is equal to 0. It can never be equal to 0. Is that a good reason? Absolutely. Because the way you find where the stationary point is, you take the first derivative, you set it to 0.
And we've wound up with a false statement.
That's right. So you just say dy dx can never equal 0, so therefore no stationary points. Okay? The three dots making a triangle stand for therefore. That's math speak. Okay, are we good?
Yeah.
Everybody cool? How many points was that?
3.
That's cool, easy 3 points. Okay, what's the next part? I. Find the
When the
volume.
volume obtained when the region is bounded by the curve, the coordinate axis in the line x equals -1 is rotated 360 about the x-axis.
I think it's just x equals 1, to be honest. I don't think it's negative.
It's not a negative one?
It's not negative. It's just positive.
It's positive.
Yeah, it's just possible.
Okay, good. I was a little worried. So it's going to be the axis, the curve, and 1. It's really pretty simple. They kind of fall into, right, they fall into the same kind of visual every time. So truly it's pi from 0 to 1, right, of 9 over 2 minus x, right, to the first power basically, squared. Do you notice that they're kind of following the same pattern now? You start to recognize that. So before I actually integrate, which people are forgetting to integrate, they'll do all the fun magic and then forget to integrate. So I need to square the 9 and bring that to, so 81, right? So I think you guys will be okay if I just say 81 pi, right? And then from 0 to 1 of 2 minus x to the -2. Okay, so the bottom is to the first power, and it's the first to the second, which means the square's on the bottom. But when I flip it up, it's -2. Are we good? Okay, now we're going to use either the substitution rule or, yeah. Sure, of course. So we're going to use either
U substitution.
Do you want to use U substitution just to see it? No.
I really don't care.
The quick method, it seems so much easier. So it's 2 minus x, add 1 whole over that times the derivative of the bottom.
What happened to the squared? How come, like, I get you brought it up and then you got -2, but then what happened to the squared?
Here?
No, before.
Okay, so the 9, it kind of came into both pieces. Does that make sense? So 9 squared is 81, and then this comes squared at the bottom, so I flip it up to be -2.
Oh, you don't have to FOIL it?
No, don't do that. Yeah, right. Yeah.
But if that was 2 minus x to the +2, we would want to FOIL it, and then each term individually we integrate.
I would. I mean, even if it's squared, you can use U substitution.
But it's just, if you can expand it out, then why not?
If you can.
Yeah.
Sometimes it's easier to expand it out. Okay, so what does this become? We've talked a little bit about my technique that makes it a little easier. Like the -1s become the positive ones. That's kind of easy, guys.
Yeah.
So that's pretty much gone. So I have 81 pi and then 1 over 2 minus x, right?
Yes.
From 0 to 1. Remember, you plug your 1 in, you plug your 0 in, subtract that, and then multiply by 81 pi. So what do you get? You get 81 pi times 1 over 2, so 1 over 2 minus 1, 1 over 1, minus 1 over 2. Do you agree?
Yeah.
Because I plug in the 1, I got 2 minus 1 is 1, and then I plug in the 0, I get 1 over 2. So what do I end up with the result? 1 minus 1/2, so 1/2 times 81 pi. So 81 pi over 2 is your final answer. Is it getting easier?
Yeah.
Not bad, really. So, part I wants me to do what?
Find a set of values of k for which the line y equals x plus k intersects the curve at two distinct points.
Okay, love that problem.
Which one is this?
I.
Oh, okay.
I.
I.
It wants me to do y equals what?
X plus k
X plus k,
intersects the curve at two distinct points.
y, and then over 2 minus x. Okay, so it says, it wants me to find the values of k for which these two lines intersect at two distinct points. When I see the words two distinct points, I automatically think of we're setting equal to factoring, a little bit more, factor it out, a little more. Two distinct points indicate I'm going to use blank. Deep down in it. A formula,
Quadratic.
part of the quadratic.
Oh, discriminant. B squared minus 4ac.
B squared minus 4ac. Two distinct points says
Is it greater?
it's going to be greater than 0.
So how do we know?
So how do we know?
How do we know whether to say it's greater than 0
Okay.
or less?
So let's review that for a minute. If it says that it meets never,
It's
Less than 0.
less than 0.
It meets at one.
Right.
Square root. So if it's less than 0 under the square root, that doesn't work.
Because it's
Right.
a negative, right? If it says it only meets once, or it's called a repeated root,
And it equals 0.
equals 0.
You got one number.
If it says it meets at two distinct points, meaning they're different,
Yeah.
then it's going to be greater than 0.
Yes.
This rears its ugly head all the time. And I told you guys when I was teaching you that, I taught it to you, and then I'll say, and then when I said, when we get to chapter 5, it's going to come back. It comes back often, okay? And a lot of times, you know how to do this technique. It's not a terribly difficult technique. People get lost, they forget the two distinct points indicate. Okay, so it's a really good review. So what I'm going to do is I'm going to take each of these things, which is what you guys were telling me to do anyway. You guys were telling me to set them equal to each other. Okay, you were telling me to try to get it to look like a trinomial. So that was part of like what you were telling me out loud in our mumbles. So I'm going to take this and I'm going to multiply both sides by that denominator because I'm scared of it, right? And I'm going to FOIL the left-hand side. So I have what? 2x minus x squared
Plus 2k
plus 2k
minus kx.
minus kx. And I'm going to bring the 9 over and set it to 0.
Yes.
Okay, I'll slow down. Ultimately, our goal is to make it look like ax squared plus bx plus c. Put the thing with x squared first. Anything with an x next. Anything without x is next. Okay, so it's going to be negative x squared. So far, so good.
Yes.
And then 2x plus 2x minus kx. That would be next, because those are, you see where I'm coming from? So I have an x squared. Anything with x's come next.
Oh, yeah.
And then anything without x's is last. So my A is what? Negative 1. My B is
2 minus k.
2 minus k. My C,
2k minus 9.
2k minus 9. Does that ring a bell now?
It's just confusing when you have the k and the x together.
I
like that.
know.
Do it.
What's
That
that?
part, I don't remember to do that formula, I just did the other way, and I gotta figure out from there.
You did?
I
Okay.
just figured, I forget that formula, just how I do it.
But you got to do it this way to get points.
Yeah.
How
Yeah.
did you get 2 minus k?
Okay, so the things. Okay, so how did I pull that out as a C, or how did I get it?
Oh, did you just factor out the x?
Yeah, actually, yeah, that's okay. There you are. So here I know X is in with these guys. So the things that don't, you just say it without the X's.
Oh.
Yeah. So
Okay.
it's 2 and then minus K. Yeah,
Okay.
that's a good way to put it. So now we're just going to plug into b squared minus 4ac. Okay, let's. And what do I know? Another question to you. When I see an inequality, automatically I should think
Chart.
Chart, that's right.
I don't think so.
But you should. Okay, so b squared, so 2 minus k squared, right? Minus 4 times a times c is greater than 0. Okay, are we good?
Mm-hmm.
I'm going to FOIL this, so I've got what? 4 minus 4k plus k squared. And then this is really positive 4, right?
Yes.
So positive 4
K
times
plus
each of
A.
these.
How'd you
So,
get,
go ahead, say it.
how'd you get 4K?
So 2 minus k times 2 minus k would be 2 times 2 is 4, and then negative 2k minus 2 more k's. We FOILed, right? So positive 8k and then minus 36.
How did you?
Say it again.
How'd you?
Yeah, that's-
How did I get one?
Oh, never mind. I see what you did.
Are you sure?
Yeah, yeah. You did the -4 and then you multiplied it into the.
Yeah, I made
You
this.
did that all in one step
Yeah.
instead of writing it out.
Right, okay, I'll write it.
No, it's okay.
Are you sure?
Yeah, I understand.
I'll fit it here.
Okay.
So 2 minus k squared plus 4 times 2k minus 9. There we go.
Yeah.
That makes it better looking. Okay, so now we're going to put them in like trinomial order, descending order. So k squared plus 4k, and then minus 32 is greater than 0.
Yes.
It screams,
I'm a trinomial. Factor me.
yeah, it does.
K minus 4 and K plus 8.
What was it?
K minus 4 and K plus 8, right?
Good job.
Yes.
So k is -8, k is 4. Remember I called those our special numbers?
Yes.
Yeah. Those are the places at which it is 0. Not greater than, not less than, it is 0. These are 2 k's that make it 0. So now what we're going to do is set up a chart. You guys remember this?
K is less than -8. K is between -8 and 4, and K is greater than 4.
Good job. This is a really good review problem. Speak for yourself, Granisky. And we're going to plug them in here. Right?
And then any values that satisfy K is less than -8, so we could say -9 would be one, or then 0.
0
Works for me.
Yep.
And truly, what are we looking for? Yes or no, right?
Yes.
So if I plug in -9 here, I get a negative answer times a negative answer.
Which is positive.
2 negatives make a positive, therefore, is it bigger than 0?
Yes.
Yes. And we kind of know where the answer is going to fall now. Let's just make sure.
Right.
Positive and negative, no, for the next guy. And then positive and positive, yes. So what are the intervals at which k
K is
less than -8
in union with.
or less than, okay. Wow. Coming. Okay. That was a really, really, really good problem. Hello? Hi. Yeah, okay. Jake, you want to talk to him on the phone? Okay, yeah, here he is. Tell.